Welcome back, math students. We are moving on to section 1.4 over functions. So let's define some key terms before we start. So first of all, a relation is any set of ordered pairs. Any set of ordered pairs. A function is a relation, so it's a specific type of a relation that assigns each x value, to exactly one y value. So basically what this is saying is you're not going to have a repeating x value. So no repeating x values. All right. Domain is a set of inputs. So those are your x values. And then range is a set of outputs. And that would be your y values. Right? Okay. So there's 4 ways you can represent a function. Verbally is by a sentence that describes how the input variable is related to the output variable. Secondly, you could do it numerically by a table or a list of ordered pairs. And then, or you could do graphically by points on a graph in a coordinate plane, or algebraically by an equation in 2 variables. So let's look at some of these. So here's our first learning target. I can determine whether the relation represents y as a function of x. Okay, so basically I'm looking to see if I have repeating x values. That's the quickest way to do it. And if you don't have any repeating x's, then it is a function. Okay? So that's my success criteria. If x repeats, then no, or not a function. And if x does not repeat, then it is a function. Then yes, function. Okay. So let's look at number 1. So I'm looking at my x values, and I don't see any numbers that repeat, so yes. And to justify my answer, I would just say each x value is assigned only one y value. So I would write that. Each x value is assigned only one y value. Let's look at number 2. I see that I have a repeating x value of -2. So this is not a function, this is no. And then I would say, to justify my answer, the x value of -2 has 2 y values. The y value of -1 and of 3. So it's not a function. You try the next couple ones on your own. All right, let's look at number 5. Oh, new learning target. Learning target. I can determine whether each equation defines y as a function of x. All right, so the first thing you're going to do is get y by itself. Okay, so I'm going to get y by itself. Ta-da! Now, if y equals a plus or minus something, then that's a no, because that's giving multiple y values. And then otherwise it would be yes. There's not a plus or minus out in front, so the answer is yes. Okay, let's try this one. So I'm going to get y by itself. To undo a square, you take the square root. So this is just y. And then when you're taking a square root, that's a plus or minus. So this is a no. Remember, plus or minus? No. All right, you try the next two on your own. Check your answers with the posted key. Okay, moving on. Next learning target. I can evaluate each function at the given value. So very simple here, my success criteria. You're just going to plug in the given x value and simplify. Okay, so let's look at one. So my given x value for this one is 13. So f of x in this case is 13. So I'm going to take 13 and plug it in for x. So f of 13 equals 2 times 13 minus 3. And then I just have to simplify. So 2 times 13 is 26, minus 3 is 23. And 23 is the answer. Let's try the next one. So plug in a negative x. So anywhere you see an x in the original equation, you're going to replace it with negative x. So it's going to be 2 times, I have an x there, so I'm going to replace it with negative x minus 3. And then I'll simplify. 2 times negative x is negative 2x minus 3. And that is the answer. Okay, next one. Now I have x plus 1. So everywhere I see an x in my equation, I'm going to replace it with x plus 1. So instead of writing this x, it's going to be x plus 1. So 2 times x plus 1 minus 3. Now I need to distribute to simplify. And then 2x, 2 minus 3 is negative 1. So my answer is 2x minus 1. You try number 10 on your own. Okay, last learning target for this video. We're going to talk about piecewise functions. So a piecewise defined function is a function defined by multiple subfunctions, which are defined over a certain interval of the function's domain. So we're going to evaluate these piecewise defined functions at the given values, so at these values here of the independent variable. All right, so how do we do this? First, we're going to determine which inequality satisfies the given x value. Determine which inequality, ran out of room, which inequality satisfies the given x value. Okay, so the given x value for this first problem, the given x value for this first problem is negative 3. So I'm going to take this negative 3 and I'm going to test it with each of these inequalities. So I'm going to see which of these inequalities is true for negative 3. So is negative 3 less than or equal to 1? Yes. Negative 3 greater than 1, no. So it satisfies this inequality. So this is the equation I'm using here. 2x minus 3, okay? So I'm going to use the equation that goes with the inequality chosen, okay? So the inequality that worked for negative 3 was this x less than or equal to 1, so I use that equation that goes with it, next to it, the 2x minus 3. Now, I'm going to take that given x value and I'm going to plug it in. So number 3, plug in x value, and then just simplify. Okay, so let's finish that up. So we're going to plug in negative 3 for x and simplify. So my answer is negative 9. Okay, let's try another one. Let's try this one, f of 1. So my x value is 1. I'm going to see which one does it satisfy. 1 equals 1, so it's this one. So I'm going to use that 2x minus 3. Now I'm going to take the 1 and plug it in for x. And solve. Okay? Last one. 3. 3 satisfies the bottom. 3 is greater than 1. So I'm going to use 4 minus x. Plug the x value in. And the answer is 1. All right, that's the end of this video.